Good morning. Myself Prabharanji, working as the assistant professor in EC department at SNS College of Technology. Okay, in this lecture video, I am going to discuss about the Unit 1 discrete Fourier transform from digital signal processing, and the topic from Unit 1 is fast Fourier transform. In the fast Fourier transform, we have to discuss the decimation in free time algorithm. Let me discuss. Okay. The problem is conversion from time domain to frequency domain is slow for long duration sequence, and also cannot able to apply the vast applications. Um, Also, filtering of the signal is also a slow process for long duration sequence. To overcome these problems, we are using fast Fourier transform. Okay, fast Fourier transform is an algorithm used to efficiently compute the discrete Fourier transform of a sequence or its inverse. That means IDFT. Inverse means inverse discrete Fourier transform in digital signal processing. The DFT is a mathematical tool that transforms a sequence of complex numbers representing a discrete time signal into its frequency domain representation, revealing its frequency components. The FFT algorithm drastically reduces the computational complexity of the DFT. Okay. Uh, DFT, the output of the DFT is nothing but the capital X of k. Capital X of k is is represented as a frequency domain. Small x of n is represented as a time domain. And the DFT, the input of the DFT is small x of n, and output of DFT is capital X of k. Okay, let me discuss some of the key features in DFT FFT algorithm. Okay, FFT algorithm are typically categorized as DIT or DIF. Here we are using two types of algorithm. One is decimation in time algorithm, and another one is decimation in frequency algorithm. Here in this lecture video, we are discussing about the only one algorithm, that is decimation in time algorithm. Okay, from fast Fourier transform. A DIT algorithm divide the input sequence in time domain, which is DIT means decimation in frequency algorithm divide the input sequence in time domain, while DIF decimation in frequency algorithm divide in frequency domain. Okay, and another main thing is butterfly operations. The core operation in the FFT algorithm is the butterfly operation. The butterfly combines pair of a butterfly combines pair of input values to produce a pair of output values. Okay. Okay. And another one is twiddle factor. The FFT algorithm pre-compute and store twiddle factor to reduce computational overhead during execution. These twiddle factors are complex exponential terms that adjust the phase and magnitude of the input values in butterfly operations. And the FFT algorithm can be implemented using radix 2 FFT is to further optimize performance. Radix 2 FFT is the most common implementation where the input sequence is recursively divided into halves until reaching base cases with 2 elements each. Here you can see Wn of r is a twiddle factor, and small a small b is the input side, and output side is capital A and capital B. A plus W, which means A plus twiddle factor multiple with B. A is nothing but the one input of the FFT, and B is nothing but the another input. capital B equal to small a minus twiddle factor multiple with B. Small a is nothing but the one input, small b is nothing but the another input. This is basic diagram for radix to FFT, butterfly diagram. And dismissing time algorithm flow graph, you can see here. uh, Starting input part is you have to take bit reversal for input sequence. That's why you can see x of 0, x of 4, x of 2, x of 6, small x of 0, small x of 4, small x of 2, small x of 6, small x of 1, small x of y, small x of 3, small x of 7. This is the input part. Say you have to take bit reversal for input sequence and 2-point sequence. This is the input of the 2-point and output of the 2-point going forward to the input of the 4-point sequence, and output of the 4-point flow to the input of the 8-point sequence. And finally the output of the DFT is capital X of 0, capital X of 1, capital X of 2 up to capital X of 7. Capital X of n is nothing but the frequency domain. Small x of n is nothing but the time domain. This is the basic decimation. This is the decimation procedure. We have to in DIT algorithm we have to decimate the total sequence depends the even part and odd part. First we have to 4-point sequence, another 2-point sequence. Here capital N equal to 8, that means 8 length sequence decimated into first 4 even part, another 4 odd part. You can see here 0, 2, 4, 6. That is for one sequence, and another this even part sequence. Another sequence is 1, 3, 5, 7 odd part sequence, and from this even part you have to decimate it into even part and odd part. Okay, and finally we get the x of 0, x of 4, x of 2. That's why here see here input side we take the bit reversal. Okay, this is the 4-point sequence, 4-point DIT flow graph. Okay, first stage is 2-point and another stage is 8-point. The formula is capital N equal to 2 power m. Capital N represent the length of the sequence, and small m represent the number of stages. Okay, if capital N equal to 4 means n equal to 4 equal to 2 power 2, which means number of stages is 2. First is 2-point and another one is 4-point. First point we have twiddle factor W4 of 0, and first stage, and second stage we have 2 twiddle factor, that is W4 of here you can see that is W4 of 0 and W4 of 1. Upper part is addition, lower part is subtract. X of 0, x of 2 input side, you can see bit reversal input is x of 0, x of 2, x of 1, x of 3. Okay, this is the twiddle factor formula. Wn of k equal to e power minus j 2 pi k divided by n. Here for example W4 of 0 we can calculate by using this formula. We can calculate W4 of 0, so e power 0, that means 1, and W4 of 1 means e power minus j 2 pi k n in 1 divided by 2, that means e power minus j 2 pi. We know e power j theta equal to cos theta plus j sin theta. Apply this formula, you can get minus j. W4 of 1 equal to minus j. This is the flow graph for 8.DIT. First 2 point, and input of the 2 point is bit reversal input x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, x of 7, and output is output of the 2 point forward to input of 4 point sequence, second stage, first stage, output of the first stage and given to the input of the second stage. Similarly, output of the second stage is given to the input of the first stage. Okay, finally we get the frequency domain, that is capital X of 0, capital X of 1, capital X of 2, capital X of 3, capital X of 4, capital X of 5, capital X of 6, capital X of 7. This is the see some example 2.4 point. Okay. Twiddle, this is the 8.80. Twiddle factor for 8.80. First stage is W8 of 0, second stage W8 of 0, W8 of 2, and third stage we have W8 of 0, W8 of 1, W8 of 2, W8 of 3. The value of this by using Twiddle factor formula, we can get the all those values. Okay, W8 of 0 equal to 1, W8 of 1 equal to 1 by root 2 minus j 1 by root 2, W8 of 2 equal to minus j, W8 of 3 equal to 1 by 2 root 2 minus j 1 by root 2. We know the formula Wn of k equal to e power j 2 pi kn divided by capital N. Okay, if k is 0 means e power 0 equal to 1. If it is 1 means we can apply this k, we can substitute the value of k equal to 1, capital N equal to 8 in Twiddle factor formula. We can get the 1 by root 2 minus j 1 by root 2, and similarly W8 of 2 equal to minus j, W8 of 3 equal to minus 1 by root 2 minus j 1 by root 2. This is the how this table show the how take the bit reversal from input sequence. For example, input sequence 1 to 7, and bit reverse it's 1 to 7 means 8 input, that means 2 power 3, 3 bit, we need 3 bit, that means 0 0 0 0 0 1 0 1 0 0 1 1 up to 1 1 1, and reverse form is for example 1 is 0 0 1, and its reversed form is 1 0 0. Its bit reversed form, bit reversal is x of 4, x of 1, bit reversal form of x of 1 is x of 4. Okay, this is the one of the examples of DIT. First we have to take a bit reversal of the input sequence. After that we have to map the input sequence value to the 4 point butterfly diagram, and find the first stage output value. This output of first stage flow to the input of second stage, given to the input of the second stage, and then we have to find the second stage of input, that is the 10 minus 2 2 plus 2j minus 2 plus 2j minus 2 minus 2 minus 2j, like this. Okay. This is the difference between direct computation means iteration and radix 2 FFT. Direct computation requires large number of computation as compared with FFT. Radix 2 FFT require less number of computation, and processing time is more when we are using direct computation, while we are using radix 2 FFT, the processing time is less, and also direct computation does not require splitting operation. Which means, for example, n equal to 8 means it is splitted into 2 point and 8 4 point and 8 point. The output of 2 point given to the input of 4 point, and output of 4 point given to the input of all those. Splitting does not require in direct computation, but in radix 2 FFT, here whether it is DIT or DIF, anything, splitting operation is done for both DIT and DIF, as the value of capital N in DFT increases, the efficiency of direct computation decreases. As the value of capital N in DFT increases, the efficiency of algorithm is increases. If you have any doubt, you can ask me through the comment. Okay, we will meet in next video. Thank you.